right, so now we should be on our practice problems for our how to calculate our average atomic mass. And we should have already answered the question in our notes, what is the average atomic mass of an element? So you can go back and reference a video about that. So first we want to practice some good problem-solving skills and go through, and we're going to underline all the numbers that we see. It says we have an element with two isotopes with the mass of 10 and 11. If the percent abundance are 20 and 80 respectively, what is the average atomic mass of the element? And then identify it.
So how would you know which percent goes with which mass?
So I would assume that since 10 is my first number that they gave me, that it's going to go with my first percent. Okay?
That makes sense.
So 11 is going to go with 80%. Now you notice one is circled and then the other one's boxed, so that's try to keep our stuff straight. So our first strategy is we're going to set this up in a couple-step process. In our second strategy, I'll show you how to condense this a little bit. So we're going to set this up in a data table where we list our masses. So I've got 10 and I've got 11. And then I'm going to put my percents beside them. I have 20% and then 80%. So the first thing that we need to take note of is we can't do math with percent. So remind us again, Ms. Vaught, how do you change it?
Okay, so we're going to move our decimal place 2 times.
Which direction?
To the left.
To the left, okay.
Oh, but wait. I'm not seeing a decimal place on there. Where would it be then to start with?
Well, you made a very good point, and if you notice, I kind of shorthanded this up here, and there is a decimal up here. So there should be a decimal right here. Fine, folks.
But what if they don't put one?
If they don't put a decimal, then you're always going to assume that it's at the end. So there's my yellow decimals. Okay, we're going to move them 2 decimal places, 1, 2. So our new decimal place is right here, 1, 2, and our new decimal place is right there. Now, our equation tells us that we need to multiply our mass times our percent abundance. But again, guys, you know you can't use a percent. So we're doing mass times the percent abundance, mass times the percent abundance. All right, so we're going to grab out our calculator, and when we calculate 10 times 0.2, we're going to get just a regular 0.2, and then 11 times 0.8 will give us 8.8. Now, it says the sum of your mass times your percent abundance. So what does sum mean when we're talking about it in math?
Well, vocabulary says that sum means addition.
Addition.
Or adding.
Or adding. So we're going to add these two numbers up, and we're going to get 10.8. Now, it says what is the average atomic mass of the element, and identify it. And our units for this are average atomic, I'm sorry, not average atomic mass. It is
AMU, right?
AMU. So we've got AMU. For average atomic mass unit. Okay. Now, if we look on our periodic table for somebody who's got an AMU or his mass number is 10.8, you would see that it would be
boron, right?
Boron. Okay. So now we're going to set this up a different way, just to give you a little bit different perspective on how to do this. My second strategy is to condense your problem so that you're not doing 3 actual several steps. You're just going to do one big one when you put it in the calculator. I still want you to approach this the exact same way because, guys, if you read this problem, it is literally the exact same problem. So I've got 10 and 11 and 20 and 80%. I'm still going to ask you to make your grocery list of information. So I've got a mass of 10 and my percent abundance is 20. And I've got a mass of 20, and my percent abundance is 80.
11.
11. Sorry about that, guys.
That's what I'm here for.
Yeah. All right. So it's still the same process as what we started. You always have to change your percent to a decimal. So we got to do 2 places. 1, 2. My new decimal place is here. 1, 2. My new decimal place is here. For now, those of you who are a little bit more math savvy, and you don't want to do 1, 2, and then the adding is actually 3 steps. I'm going to show you how to get this all in one. Parentheses are an amazing thing. It's called order of operations, and we want to make sure that everything in parentheses gets done first. So the thing that we did first was we did 10 times 0.2, and then we also did 11 times 0.8. The next step that we did after making sure that both of those got multiplied is we took the sum. Remember, sum is adding. And if you are to put this in your calculator exactly as it is shown right here, you will literally get the exact same number, which is 10.8 AMU. All right, so we're on to our second problem. Our second one says that we have 77.35% of the atoms of an element have a mass of 35. So we know that 35 has this percentage right here. The rest of them have a mass of 37. Calculate the average atomic mass and the identity of the element. So we're going to go through and make our grocery list again. We've got 35 and 37 for our masses. And then I go and I find that 35, its percentage is 77.35. And they didn't give me my other percent. So if I'm working out of 100%, Ms. Vaught, how would I find that other percentage?
Well, all percentages are based off of 100%, so 100 minus 77.35 is 22.65%.
You're awesome.
I know.
All right, so we've got that going on. The first thing that we're going to do is we are going to change our percents to a decimal. Multiply those.
Okay,
So we've got 1, 2, 1, 2, and then we're going to multiply. Remember, we're going to multiply these two, so our first one is going to be equal to 27.07. Now, you might have more decimals than that, but we're going to keep it at 2 decimal places. And our next one is going to be 8.38. So, we've multiplied our mass times our percent abundance. Our last part is to get the sum. Sum is to add. So we're going to add those two up together. All right, and we get 35.45. Now, Miss Vaught actually has this really cool way to check yourself.
Okay, well, the big thing is that if we had 77%, 77 is a fairly large percentage, and it says 35 goes with the 77%. So our answer should be pretty close to 35.
Because most of it was 35.
Exactly.
Okay.
Whereas only 22% was 37, so your range should still fall closer to 35. But overall, your average should still be somewhere between 35 and 37. If we had ended up with an average atomic mass that was like 40, then we know that's right out because that does not fall in between our numbers.
Gotcha. Great. She's always got good ideas. All right. So, again, guys, it's the same problem as we have below. We're going to use a second strategy and put this all in our calculator as one big step instead of 3 little ones. So we're going to do what we wanted to do first, which is we've got to take a mass of 35 and multiply it by our decimal of 0.7735. And then the other step we did first was 37 times 0.2265. So we want those to be done first. And then we're going to put an addition sign in between them because at the end we want them all to be added. And guys, at the end you will still end up with 35.45 and it's AMU.
And if it has an average atomic mass of 35.45, what element is that?
We look on the periodic table, so we can pop our periodic table down real quick. And 35.45 would be
Chlorine.
chlorine. So our atom will be chlorine.